Okay, hello. I hope it's okay to do this as a video. It was going to be too hard to write this out and explain it. Anyway, so your question was, explain how your graph of y equals x squared take 8x plus 12 can be used to solve this guy on the right-hand side here. Okay, first thing I'm going to point out is that y equals x squared take 8x plus 12 is the first equation there that's given. So where else can we use this to solve this thing on the right? So the first thing that I'll do there is just point out that if I factorized this expression, so as in I need two numbers that add to give me multiply to give me positive 12 and add to give me negative 8. Well, they multiply to give me a positive, so they can either be both positive or both negative, but they're adding to give me a negative just here, so it means that both numbers have got to be negative. So what will work for that is, well, 6 times 2 will give me 12, and they'll also add, so negative 6 and negative 2 will add to give me negative 8. So they're equivalent expressions but factorized. Yes, mate? Yeah. You going to wave? There will be a brief intermission while I do this. Here you go. Finny. I've done it. Are you going to help me? I sense you won't be much help, but that's fine. Okay, so what I'm getting at here is that this expression here, so x squared take 8x plus 12, is the same as x take 2 bracket x take 6 just here. Now that's talking. So what we're going to do now is say, well, now that we've established that they're essentially the same expression, I'm going to write that one that we need to solve just here. So negative 3 equals x take 2, same thing as the one above, it's just in a different order, x take 6. Okay, so what it's asking you here is explain how your graph can be used to solve this equation there. So essentially, what it's asking you is what values of x, and there's going to be more than one of them because it's a quadratic, will give you an answer of negative 3 when you plug it into this equation. But don't forget that for a question like this, because it's a quadratic and it's got that x squared in there, remember that if we do negative 3 squared, we get 9. If we do positive 3 squared, we get 9 as well. That's why we get this shape of the graph, because it works for a positive and negative values for this one. But what the question is asking is, hey, how can I use this graph to get an output of negative 3 when I have an input of whatever x values it is that I'm looking for? So if I read y equals negative 3 off the graph just here, and look at where my intercepts for the graph are, you'll notice that if I look up to the y-axis, I see that I get that answer of negative 3 if I either put in x equals 3 or x equals 5 into the equation. And I can show you that real quick, I suppose, just to show you that that would work. So if x was 3, we'd have, I'm hoping that you can see this, we'd have, I'm not going to write out the full thing, but we'd have 3 take 2, which is 1, multiplied by 3 take 6, which would be negative 3. So negative 3 equals negative 3 over there, obviously. And then if x was equal to 5, we've got 5 take 2, which is 3, and then 5 take 6, which is negative 1. Negative 1 times 3 is negative 3. So that works. Yeah, mate. Are you getting a bit bored? I will be in a second. Okay, so when it says how do you explain that you can get that solution? Pretty much saying that you need to read your y values off the graph, because don't forget that for every one of these coordinates, so say here 2, 0, here we've got 6, 0, down here we've got 4, negative 4. I'll put all of those in brackets because it's a coordinate, mate. Don't forget that all of these are coordinate pairs that fit the equation. So if you've got an input of x of 2, you'll get a y input of 0, and so on. Cool. I explained this concisely? I hope so. So then you're saying state the solutions to this. So your solutions for that, your x values that will give you an output of negative 3 are 3 and 5. So I'll be indicating them on the graph kind of like this.